Have you ever wondered what happens when you mix things together? Sometimes you just get a simple mixture, like sand and water. But other times, something amazing happens. Something new is created. That, my friends, is a chemical reaction. It's like a grand dance where tiny particles called atoms decide to switch partners. They break the bonds holding them to their old partners and form brand new bonds with new partners. This isn't just mixing, it's a complete transformation. Think of it as taking apart a toy car and a toy airplane and using the pieces to build a fantastic new flying car. The original toys are gone, and something entirely different has taken their place. Science is cool. So, what are these atoms and bonds? Everything around us, the air we breathe, the food we eat, even you and me, is made of atoms. These are the super tiny building blocks of the universe. When atoms join together, they form molecules, held together by connections called chemical bonds. A chemical reaction is the process that rearranges these atoms. The starting materials, which we call reactants, go into the reaction. They undergo a change, a fundamental rearrangement of their atomic structure. What comes out are the products, which are completely new substances with different properties than what we started with. It's a fundamental principle of chemistry, happening all around us, all the time. Let's break it down even more simply. Imagine you have hydrogen gas and oxygen gas. They are both invisible gases, but if you provide a little spark of energy, an incredible chemical reaction happens. The hydrogen and oxygen atoms break their bonds and rearrange themselves to form something we all know and love. Water! You started with two gases, and you ended up with a liquid. The properties have completely changed. This isn't magic, it's science. It's the universe's way of building new things from old parts. This process is happening constantly, from the sun shining down on us to the digestion of your lunch. The key takeaway is that a chemical reaction is not just a physical change, like ice melting into water. In a physical change, the molecules stay the same. H2O is still H2O, whether it's solid, liquid, or gas. But in a chemical reaction, the very identity of the substances changes. The starting materials, the reactants, are consumed and disappear. In their place, brand new substances, the products, appear. This transformation is the heart and soul of chemistry, a powerful force that shapes our entire world from the smallest cell to the largest star. Consider the possibilities. So, how can we tell if one of these amazing chemical reactions is actually happening? We can't see the atoms dancing around, but we can look for clues. These signs are like signals that tell us a chemical transformation is underway. One of the biggest clues is a change in temperature. Many reactions release energy, making things feel hot. We call this an exothermic reaction. Think about a campfire. Burning wood is a rapid chemical reaction that releases a lot of heat and light. On the flip side, some reactions absorb energy from their surroundings, making things feel cold. This is an endothermic reaction, like the one in an instant cold pack. Another fantastic clue is a change in color. Have you ever seen a green banana slowly turn yellow? That's a chemical reaction. The pigments inside the banana's peel are changing as it ripens. When you toast a piece of bread, it goes from pale white to a wonderful golden brown. That browning is a series of complex chemical reactions called the Maillard reaction. So, if you mix a couple of clear liquids together and they suddenly turn a brilliant blue or a cloudy white, you can be pretty sure you've just witnessed a chemical reaction. It's a visual sign that the old substances are gone and new ones have been formed. Sometimes a reaction will bubble and fizz. This is a great sign that a gas is being produced. A classic example is dropping an antacid tablet into a glass of water. The tablet contains baking soda or sodium bicarbonate and a solid acid. When they dissolve in water, they react to produce lots of carbon dioxide gas bubbles. You can see the reaction happening right before your eyes. This formation of a gas where there was none before is a very strong indicator that the atoms are rearranging themselves into new molecules, some of which happen to be in a gaseous state at room temperature. Finally, you might see a solid suddenly appear out of a liquid. This is called the formation of a precipitate. Imagine mixing two perfectly clear, salt-like solutions together. Suddenly, the mixture might turn cloudy, and you'll see solid particles start to form and sink to the bottom. It looks like a little snowstorm inside your beaker. This solid is a new substance that doesn't dissolve in the liquid, so it precipitates out. These four signs, a change in temperature, a change in color, the production of a gas, or the formation of a solid, are your detective tools for spotting chemistry in action. Let's bring this into a place we all know and love, the kitchen. The kitchen is one of the greatest chemistry labs on Earth. Think about baking a cake. You start with a gooey mixture of reactants, flour, sugar, eggs, and baking soda. Each has its own properties. But after you put it in the hot oven, a flurry of chemical reactions begins. The heat provides the energy needed to get things started. The baking soda reacts to produce carbon dioxide gas, which creates all the little bubbles that make the cake light and fluffy. The proteins in the egg and flour change their structure, giving the cake its solid form. The result is a delicious golden brown cake, a product that is completely different from the sticky batter you started with. You can't just unbake a cake to get your eggs and flour back, can you? That's because the original substances have been used up and transformed into something new. The browning on top is that Maillard reaction we talked about, creating hundreds of new flavor and aroma molecules. Every time you cook, you are a chemist, experimenting with reactions to create new textures and tastes. Cooking is science you can eat. It's a delicious demonstration of how reactants are transformed into products. Now let's step outside. Have you ever left your bicycle out in the rain? You might come back to find reddish-brown, flaky stuff on the metal parts. That's rust. Rusting is another very common chemical reaction. The reactant is iron, or steel, which is mostly iron, and it reacts with another reactant, oxygen from the air, in the presence of water. This slow chemical reaction forms a brand new substance called iron oxide, which we know as rust. The strong, shiny iron has been changed into a weak, crumbly, reddish-brown powder. The properties have completely changed for the worse. This is a great example of how a reaction uses up the old material to create a new one. The more rust that forms, the less solid iron you have left. If left for a long time, the entire piece of iron can be consumed by the reaction and turn completely into rust. This shows us that chemical reactions aren't always helpful, like baking a cake. They can also be destructive. People spend a lot of time and money painting metal or coating it with other materials to prevent the reactants, iron and oxygen, from meeting and starting the chemical reaction of rusting. It's a constant battle against chemistry. So why is all this important? Well, take a deep breath. The oxygen you just inhaled is about to take part in a vital series of chemical reactions inside your body's cells called cellular respiration. Your body uses that oxygen to react with sugars from the food you've eaten. This reaction releases the energy that powers everything you do, from thinking and running to simply keeping your heart beating. The products are carbon dioxide, which you breathe out, and water. Without these continuous chemical reactions, life as we know it simply couldn't exist. You are a walking, talking, thinking chemical reaction machine. Look around you. The clothes you're wearing are likely made of synthetic fibers like polyester or nylon, which were created through massive industrial chemical reactions. The plastic in your computer mouse, the paint on your walls, the medicine in your cabinet, all of these are products of carefully controlled chemical reactions. We've learned to harness the power of chemistry to create new materials with incredible properties that don't exist in nature. From creating super strong building materials to developing life-saving drugs, our entire modern society is built upon our understanding and control of chemical reactions. Even nature itself is a master chemist. Think about a tiny seed growing into a giant tree. That process is powered by one of the most important chemical reactions on the planet, photosynthesis. Plants take in reactants, carbon dioxide from the air, water from the soil, and energy from sunlight, and use them to create their own food, sugars, and the oxygen we breathe. This reaction not only feeds the plant but also produces the oxygen that most living things on Earth need to survive. It's a beautiful, life-sustaining cycle, all driven by the magic of chemistry. From the battery powering your phone to the fireworks that light up the night sky, chemical reactions are everywhere. They are the engine of change in the universe. They create, they transform, and they power everything. By understanding what a chemical reaction is and how it works, we gain the power to solve problems, create new technologies, and better understand the world we live in. So the next time you see something change color, heat up, or fizz, give a little nod to the incredible invisible dance of atoms. It's not magic, it's something even better. It's science,